On the same day, two very different companies crossed the same financial line. Alphabet, the company behind Google, generated about $39 billion in cash from its operations during the quarter. It spent nearly $45 billion on capital assets. Tesla generated about $4.7 billion and spent about $5.8 billion. In both cases, construction outran current operating cash. This is not proof that either company is in trouble, and their businesses are not directly comparable. But together, the numbers reveal something easy to miss when artificial intelligence appears as a clean box on a screen. AI is becoming an industry. Capital expenditure buys things expected to last. Land, buildings, servers, cooling systems, substations, manufacturing lines, and the equipment inside them. Alphabet says most of its spending went to technical infrastructure. Tesla says its program includes AI compute and data centers, but also factories, vehicles, service centers, and charging. So not every dollar can honestly be called AI. The deeper point is physical. A request that feels weightless to the user depends on chips fabricated years in advance, transformers with long delivery times, concrete poured near available power, and machines built before anyone knows exactly how much useful work they will perform.
There is real demand. Alphabet reported that cloud revenue grew 82% from a year earlier, and that its backlog reached more than $500 billion under a recently expanded definition. Tesla reported 1.48 million active subscriptions for its supervised driving system, and more than doubled its on-site AI training compute in the first half of the year. These are meaningful signals. They are not the final answer. A token processed is not automatically a profitable token. A subscription is not the same as an autonomous vehicle. A contract backlog does not tell us the return on the newest data haul. And company usage does not yet measure whether a hospital, factory, school, or small business is becoming more productive. That creates the central tension of the build-out. The assets must be financed now, while the return arrives later, if it arrives at all. Alphabet raised roughly $50 billion through common and preferred equity, and another $20 billion through senior notes. Its filing also reports hundreds of billions in future fixed or guaranteed commitments, mostly long-term supply arrangements. Those commitments are broader than AI, and Alphabet remains a highly cash-generative company. Still, the direction matters. The race is recruiting shareholders, bond markets, suppliers, utilities, and governments into decisions whose useful life may extend far beyond today's models.
Then, the build-out meets the grid. The International Energy Agency estimates that global data center electricity use could roughly double by 2030. In the United States, a recent national laboratory study places data centers somewhere between about 10 and 15% of electricity use by then, depending on the scenario. These are forecasts, not destiny. More efficient chips, different models, slower construction, or new generation could change them. But power is already changing where facilities can be built and how quickly they can connect. The Department of Energy is even studying rapid, synchronized swings from large computing loads. A smooth answer on the phone can begin with a very unsmooth problem in a control room. A new machine also does not create productivity by simply arriving. Businesses have to redesign work around it. Staff need training. Data must be cleaned. Mistakes need owners. A clinic may save time drafting notes, but spend more time verifying them. A warehouse may predict demand better only after inventory systems change. Economists call this delay the productivity J-curve. Investment can rise before measured output does, because the complementary work is real, but difficult to see. That means today's weak return could be temporary. It also means more spending cannot by itself prove that the missing productivity will appear.
We have seen that ambiguity before. During the internet boom, companies laid enormous amounts of fiber optic cable. Much of it initially sat dark, and some builders failed. Yet later services inherited useful network capacity. The lesson is not that AI is another dot-com crash. The technologies, markets, and constraints are different. The lesson is that two statements can be true at once. Society can eventually benefit from infrastructure, while particular investors build too much, too early, in the wrong places, or at the wrong price. Public value and private return are connected. They are not identical.
Several futures remain plausible. In one, abundant compute becomes a utility for useful intelligence, cheap, reliable, and woven into ordinary work. In another, the benefits are real, but uneven. Large firms secure power, chips, and premium capacity, while smaller users rent what remains. In a third, demand grows more slowly than construction, leaving underused halls, renegotiated contracts, and losses that do not erase the technology itself. These outcomes can overlap across countries and industries. No earnings call can tell us which mixture will emerge.
So watch three things. First, utilization and unit economics. Are the new machines doing paid, useful work as their costs fall? Second, productivity beyond the builders. Are ordinary organizations producing more or merely buying another subscription? Third, the distribution of cost. Who funds the grid, carries the long contracts, absorbs unused capacity, and receives the savings? Those tests are slower than a stock price reaction. They are also closer to the question that matters to everyone outside the earnings call.
Artificial intelligence still arrives as words, pictures, directions, or code. Behind that instant response, an industrial system is taking shape. Silicon, steel, electricity, factories, contracts, and borrowed time. Alphabet and Tesla did not prove that the bet will succeed when they crossed that cash flow line. They showed how large the bet has become. The hidden order is not inside one model. It is the network of physical and financial commitments forming around all of them. Whether that network becomes productive infrastructure, expensive overcapacity, or some uneasy combination, will not be decided by how impressive AI looks today. It will be decided by what all this construction allows people to do tomorrow.